Hello everyone, welcome to Engineering Escapades, and now I know I'm very zoomed in, but it's because we're doing some actual electronics in this video, finally. So just to show you what I'm going to do in this video. This little guy, if we could get the camera to focus, please. Okay, so this little guy is a transistor, and I don't know if it's obvious right now, but it has 3 leads, it has 3 legs. And this guy functions kind of like a switch would. So when it's on, it allows current to flow, and when it's off, it blocks current, essentially. And it doesn't exactly do that. It acts more like a very, very, very large value resistor, but I'll get into that in another video on how these actually work. Today, I just want to show you how these actually work in your computer to allow for signals and stuff. So what I'm going to show you first is this little circuit here, and as you can see, when we flick this switch, it allows a current to flow through here and to ground. But since there's a resistor here, some of the current will want to go through the base of the transistor, which is the middle pin, and then through to the emitter, which is the leftmost pin in this case, and to ground. And what this does is that a current flowing from the base to the emitter allows a larger current to flow from the collector to the emitter. And you'll see that here I have an LED hooked up. Now I've just drawn this as a diode, but this is actually the LED that is here. And you'll also see that I have a resistor in series with it, and this is just a 150 ohm resistor to give about 20 milliamps of current through this LED, which is the max rating, by the way, so it's going to be pretty bright. But as you'll see, when I click the switch and close the circuit, you'll see that current flows through the transistor, and turns it on, and allows current to flow through the LED to ground. And as you'll see, that lights up the LED. Great! Now this next circuit I'm going to show you is pretty much the same, but it's something that we can actually use for signal. So we don't want to use this for logic because quite a large current flows. 20 milliamps is actually quite a lot. So we can make that lower by only using a signal that is a lot less, if that makes any sense. So here I have a 3K resistor hooked up that goes to ground, and this is 3K and this is 3K. They're all 3K, and there's no specific reason for it, and except that it just works. So you'll see that when I switch this, when I flick this switch, it will allow the current to flow from 5 volts through the transistor, and you'll see that this time the resistor is on this side, and we take the output signal here. And the reason for this is that the output is, of course, with respect to ground. And with respect to ground, at this node, right now, after the transistor, it's 5 volts. And because it's 5 volts, we can use that. So if we just unhook this switch right here, remove this, or we place this resistor here instead, because we do want some current limiting on that. We don't want to just fire current straight through it. And what you'll see is that when I take this and connect, so when I take the output here, so I'm here right now, and when I take the output and plug that into the resistor, you'll see that nothing happens. But when I turn the switch on, you'll see that it turns on. So that's pretty cool, but it doesn't really allow for much special. But this is the ground, this is the foundation of how signals in your computer go back and forth. So signals like these with very low current allow for larger signals, or allow for other signals, essentially. So we could have this going into another transistor and another one and another one, but here I just have one that gives a signal to this circuit right here. Now, you might be wondering, what is this one? It looks very similar to this one, but if we scoot over here and let's just have a look at this circuit first. So, just try to imagine in your head what happens when I take this white cable and attach it to the output of this circuit. Now, you'll see this output is immediately connected to 5 volts, right? And what happens here is that we actually have a 5 volt potential at this node. Now, these are all just 3K resistors as well, but it's not really important. You'll see that the potential here is 5 volts. But when I turn the transistor on, it allows current to flow through the transistor straight to ground. And this acts as a essentially short circuit to ground. And what then happens is that the potential here drops to 0 volts when it's on. So what we would expect to see is that when this switch is not pressed, we'd expect to see that the LED is on, and when it is pressed, we'd expect to see it is off, and hence the name of this circuit, an inverter. Now, if we just plug this in, you'll see that the LED just turns on, and when I click this switch, and you'll just have to believe that I'm actually clicking the switch, the LED turns off. Great. Now, that's pretty much all for this video. That's just how to show you how a transistor works. But in the next video, I'll probably go through a few logic gates, how you do logic with these. And yeah, I think that's pretty much it. Thank you for watching, and I'll see you guys next time. Bye-bye.